the symbol we use typically like this. Some to show that it's a vector quantity, we use that bar, average velocity is defined as displacement by time taken. Let me, I need some vector idea. So initially the position is here, or we'll take this initial position. And let this be the final position. So we define position vector R1 bar, this R2 bar. T equals 0, it was here. After some time t, the particle is here. Then now you define the displacement final position minus initial position. So this will be V average is equal to delta R bar by delta t. Delta R bar final position vector minus initial position vector by time interval. Look at R2 bar minus R1 bar. So if you know some vector analysis, R2 bar minus R1 bar is needed. So this is R2 bar. This R1 bar minus R1 bar will be like this. Minus R1 bar will be in this direction. Then if I shift it, minus R1 bar, this R2 bar. So how delta R bar, this will be the delta R bar. Okay, fine. So I'll bring now the vector. So what is telling, the displacement average velocity will be directed like this. This is the delta R bar. What about path? How will move? It will move some path, some random path, let it be. The person is initially here. He will walk like this. There's a path and he will reach here. What about the average velocity, the displacement by time taken? We define like this. Now look at, there is so many things we have to be carefully, we have to analyze. So now person, how is moving? So it's moving along red color arrow. No, this is a path. I'm saying path, you must understand. Or like the person will move along this green color line. How it will be directed? It is independent of the path, no? It will be always directed from initial to final point. Suppose a person moves like this, then also delta R bar will be like this. If person moves like this, then also delta R bar will be like this. So shall I say that the average velocity is independent of nature of motion and depends only on delta R bar? The first point, V average bar is independent of nature of motion and depends on displacement. Again, same thing, V average, displacement can be positive, average velocity, V average can be positive, negative, or zero for a motion. It will have unique value. V average will have unique value for a motion between 2 points. Next, one more. Direction of average velocity depends on resultant displacement vector. Resultant displacement vector. How we define? Basically defined as ratio of displacement by time taken. Is defined as ratio of displacement by time taken. It's a vector quantity, no doubt. It will be different for different path, no doubt. Okay, let me give one example. Let me choose I'll come to that.